Hi everyone, and welcome back to 3.1 continued. And in the first video we learned what a quadratic function looks like. It's going to be a parabola that opens upward or downward depending on what that leading coefficient, we like to call the number in front of the highest power of x, the leading coefficient. So this is a -2, so we will have a parabola, that wonderful U shape, that is going to open downward, which has a vertex at HK. So we need to put this in standard form so we can find that HK. So we're going to kind of go through the analysis of this function, and that's kind of what math analysis is studying. So analyzing functions, being able to pick out all the details from an equation of a function. What it might look like, where the maxes are, minimums are, and so forth. So let's kind of go through that. So let's look at this one, and again we're going to put it in standard form. So we want to go to standard form, so I'm going to write that down. We want to go to standard form. So that means we want to complete the square. And this completing the square is a skill that needs to be practiced, because we are going to see it again at the end of the semester when we do conic sections. So it is something that you will use from time to time, and so you kind of want to get good at it. So that if you're not good at it yet, make sure you do some extra practice. So that you can get better at this completing the square. Okay, so completing the square. Remember, that's going to be putting it in this ax minus h squared plus k form. So to do that, first thing we're going to do is get rid of that a and pull it out front. And this a is that leading coefficient. So we're going to pull that -2 out. But I'm not going to pull it out of everything, because I don't need to pull it out of the 5, because that's going to become part of this k. So I'm going to just pull it out of the x squared term and that x term. So pulling it out here becomes an x squared. And then notice a negative pulled out of a negative does turn it to a positive. Lots of mistakes I see there, so that's going to turn into a plus 2x. I'm going to leave a little space because we are going to complete the square, complete that perfect trinomial. And we're going to pull that -5 off a little bit. Now comes the completing the square. So the technique is take that x, we do half of the 2, which is 1, and then we take this guy and we square it, which becomes a plus 1. And now what we have to remember is that we can't change our problem. So this, by putting this plus 1 here, we're actually looking at the distribution, subtracting 2 from this problem. So in order to undo the subtracting of 2, we have to add 2 to this problem as well. So we can undo that. And then we would have that -3. So I'm going to put my little square there, completing the square, and then minus the 3. Note, you can check your work. FOIL this out, distribute your -2, combine all your like terms. You should get it back to where you started. So this is just taking this thing and rewriting it in a more useful form, in a form that we can pick out what the vertex is. So this is going to open down, and we knew it opened down because this leading coefficient was negative, and it has a vertex at, notice it's x minus h, so it's going to have a vertex of -1 and then -3. So if we were graphing this one, it would have shifted the normal x squared function from its standard vertex at 0, 0 opening up, would have shifted it to the left 1, flipped it upside down and stretched it a little bit, and then shifted it down 3. Okay, so I'm going to kind of draw on a rough sketch of what we got so far. we will add to this. Okay, so -1, -3. And we know it opens down. Okay, so right now I know that I have a maximum value of -3 that happened at x equaling -1. Okay, to help me continue this graph, we might want to find our x and y intercepts. So we'll do the y-intercept first. And to do that again, we let x equal 0. So going back into this original equation, letting x equal 0, 0, 0, -5. So we are at 3, 4, 5. Okay. Since it is symmetric, I'm going to put in another point right away. I should have done that on my first video, but because it is nice and symmetric. X-intercepts. Okay. That's where it crosses the x-axis. And on this one, if you look at what the graph is doing, it's opening downward. Okay, which means it's not going to turn around and come up and hit the x-axis. So we will not have any x-intercepts. So there are no x-intercepts. So if you had tried to solve that equation, and I'm not going to do that, but I will just kind of talk through it. First thing I would have done is multiplied both sides by a -1 to get rid of all those negatives floating around there in there. I like to have my leading coefficient equal to a positive value. Or you could have moved them all to the other side. That would have worked as well. Same effect. And if I were to try to factor this one, I would find it would not factor, because if it did factor, that meant I would have had x-intercepts. Also, when I go to the quadratic formula, I will get imaginary roots. So I will have imaginary solutions here. And this is how you can kind of tell of what's going to happen. When you have imaginary solutions of a quadratic, that is going to be a parabola that either opened down and was below the x-axis, or if we had one up here, that's when we'd see those imaginary solutions. Okay, we can get this vertex. So there's a shortcut to the vertex. And in the textbook, it does go through where that vertex happens. And I'm going to write what we have from our textbooks. They call it a shortcut to the max or min. So that max or minimum value of a quadratic function f of x, and we're going to put it in its general form, ax squared plus bx plus c, occurs or happens, or we get it when x is equal to a negative b over 2a. Okay, and this negative b over 2a does come from that quadratic formula part, but I want to kind of look at what we had in this last one. So we had this function here, whoops, where are you? That negative 2x squared, and I'll write it down on a new piece of paper so I don't have to. There's my function. Okay, and I want to find my, first of all, max or min. First of all, I know it's going to be a maximum because it is a negative a value, so it does open downward, so I know I'm talking about a maximum. And if I look at my negative b over 2a, so that's a negative 4, so that's 4 over 2 times this negative 2. 4 over negative 4, I get negative 1. And you'll notice that that was the x value of our vertex. We can find the actual value, so this is going to be our max value, by putting that -1 into our function. So -1 squared. Okay, so this is going to be a -2 plus 4 minus 5. So -2, that's a +2, minus 5 is -3. Notice our vertex in the problem we had was -1, -3. So this is a kind of a quick way of getting at that vertex. If all you needed was the max and the min. If all you needed was where did it happen, we could have stopped there. If I actually need the actual value, we have to go that one step further. Okay, I have one more problem that I want to talk about in this video, and then we'll move on to the next section. And that, well, actually, sorry, two. And let me think. Actually, I think I'm going to stop this video because these might take longer than I want, and I'll put them in another video. So I'm going to stop this video, and we're going to do some word problems in another video.